Okay, so good morning, all of you. So today we'll be talking about modeling part. We will try to learn what modeling and simulation is. Uh, Mostly we will be talking on philosophy, not actual models, because then actual model, even if we wanted to just describe one model in depth, it might take more than 2 hours to understand all nitty-gritty details. So mostly we'll be restricting ourselves to philosophy of that particular different model which exists, and how starting from very basic model till comprehensive model, which might be more appropriate for Indian context. Few of them, obviously we may not able to cover all of them. So starting from that, so this is okay. So there are two words, modeling and simulation. So what do you mean by modeling? So any is like, we are not asking for like any formal definition. So
anything which makes the real life problem to mathematical equations in the form of mathematical.
okay, so anybody else?
Creating a real life situation in a very small scale.
Creating real life situation is also, that is also a model. Yes.
Yeah, structuring something based on a requirement.
Okay. So like whatever you said, like most of them are correct. Like first thing, that model means like we are trying to mimic the real world. So they will not be exactly at a real world, but if you extract the parameters depending upon what is your intention is, what level of modeling you want, then parameters might be matching. But if you take a snapshot of the simulated stream, for example, and real time stream, even though you are simulating same stream, vehicle to vehicle it may not match. But if you start measuring, say, time headway distribution, vehicle composition, maybe speed distribution, all those things supposed to be matched if your model is developed for that kind of that level. So that is like basically modeling means like we are trying to mimic, we are trying to present the a real life scenario with a simplified version, because like once you try to do modeling, a lot of assumptions are involved. Assumptions are required to simplify the complexity. Like once we say start modeling the traffic, majority of time we consider that all the traffic consists of cars, which may not be true. Or maybe even car has different variety, but we consider that like our cars are same. Even sometimes we consider our drivers are same, depending upon the different labels. So those are nothing but like simplification of the reality, and they are like basically conceptual representation of some real system. Or sometimes like it might be in mathematics terms, in form of equation. Sometimes it might be physical terms, like you are in real life dam structure is like huge, but you are building a smaller scale model in lab so that you can study and do some kind of experiment. But these model and real structure, they had some kind of relationship. There might be whatever characteristics you observed at model, you will be able to translate into the real world structure. So that is like called modeling. Now next question comes like, if this is the modeling, then what is the simulation? So because these words like sometimes come together or maybe separately, but most of you, if you are aware of model, you also always like encounter simulation word as well. Yeah, one by one. Yeah, please. This is also virtual environment, or maybe I don't know, computer model you consider as virtual or physical or what?
The form of animation, but here in modeling, we mostly solve mathematical equations.
So modeling, like even physical modeling also might be modeling. So simulation, you are saying in virtual world we do.
Virtually, we solve the problem by defining the environment perfectly.
And mathematically also, whatever model we describe, the same definition. So what is the difference? Is there any difference? First question is that whether modeling and simulation are different, are the same? If they are different, what is the difference?
Testing the model using model.
Using model is
Maybe
okay. Yeah, madam. Yeah, many of these are not working because I think charging is not there or something. So even these two are not working. Maybe you can just check. So this testing the model. Okay. Anybody else?
basically applying it so many times that we get the results are real time. They are routines.
That is like calibration, not simulation. It's like you wanted to fine tune your model so that it matches with like.
Create some conditions similar to the real world so that the model works well.
So that is the model also. Like if it is not mimicking the real world, then it is not a model.
Yeah, but the external conditions will be given to that. That is simulation, like traffic flow propagation.
Okay. Anybody else wanted to attend? Okay. This we skip. So we'll come to simulation like little later. So let us talk about what are the different type of model. You can have physical model, mathematical model, and then process model. So in a physical model, like might be you can create like dam example, whatever say. Like maybe even sometimes we do the like multi-story buildings study in terms of like if wind velocity is high, what will be the swing, or if you create like all surrounding building environment, and then if you are going to build a high-rise building in between, how the wind movement will be. That is like normally we conduct with through physical model in wind tunnel. Then mathematical model, you are very much aware of all this traffic flow model is nothing but mathematical model. Then process modeling. So whatever coding steps, that can be another model, but that is like in form of flowchart and rules. Sometimes it's not like your model may not be either of them, might be combination of those, some physical, some mathematical, both together. So but our traffic flow model is mostly like belongs to mathematical model, where mathematically we try to develop some kind of relationship between different components of the system. Like what are the three component of the traffic system? So driver, roads, and uh, roads, and vehicle. So among that, how they interact with each other, we try to express into mathematical term. So that become our mathematical model. So if you want to study a system, either you can do experiment with the actual system, then you can learn that how system is responding, or you can create a model and then experiment with this. So if you are able to create physical model, you experiment with the physical model, or you develop like a kind of mathematical model and then try to test that model in different scenarios, then you come up with this kind of environment. And sometimes these two terms like will come back later. So sometimes this mathematical model you can easily get the answer or solve it by analytical method, by using some kind of analytical tools. But sometimes it is not possible. So why it is not possible, when it is not possible, and then how simulation comes into picture, that we'll try to see. We'll skip this, yeah. So we'll try to understand what simulation means. Now, if this is a box, which is a transparent box, and all the sides of this box is perfectly elastic, and that elasticity coefficient, everything is known. Even ball's elasticity coefficient and initial position and the speed is known. Now, if we shake this box by a known force, so everything like will move, balls will also move, and they might collide with each other. Okay, so if they collide with each other, they might take some time and then collide. They might be rebounds back. How to get their position? So for that, like there is well-known maths available, equations are available, dynamics equations are available. If you know the initial condition, we can figure it out. Like it's like very deterministically you can figure it out if the all the parameter is known. So this is not a simulation. So because like here you are able to get the answers with the mathematically directly solving this equation using analytical method. What will happen if we add few more wall, like maybe one more wall if we add? So can we write equation for all three? We can. It's easy to write like equation to write for 3. If we add 4, slightly difficult, but because now there are too many permutation combinations. They might be colliding each other as well as they might be colliding with the box surface. So number of equations are increasing. If we keep on adding more and more, then solving those equations all together is challenging. So now if we had this system like which has like a large number of such components, then even though between two components how they interact, that relationship is known, but it is difficult to tell that how the system will behave after some time. And here simulation comes into picture. So that mathematical model, how it will perform over time dimension. So basically we are adding that statistical mathematical model to dynamic dimension, like maybe time dimension, that over the time how it will be interacting with each other using the same relationship. Here also, even though we are doing simulation, but at the back end the same equation is we are going to use. We will be considering that vehicle first ball combination, second ball combination, third ball combination might be 1 lakh. All combination we will figure it out, then we will update the position at next time step, maybe after 1 second. Again we will be using the same equation, trying to figure out what is the next update. So once we get the position at every regular interval, and if we start creating the animation of that you called simulation. So that becomes like more dynamic than the relationship whatever we have modeled. So this like that is why like many of the time you will see this modeling and simulation interchangeably people keep on using. So there is like very fine difference, but in like traffic field, because it's not a static system, it's dynamic system. So your modeling will be the relationship which you will be defining between two atoms. That always you will say that it's not like Gibbs simulation, you will not say. This is Gibbs model, which tells about two components, how they are interacting with each other. And if you add third dimension T, that over time different large number of such components, if they are interacting with each other, that becomes simulation. Okay, so now this is clear. Okay, so we will be talking about models, which will talk about the components. Now if you consider traffic system, we had three basic components: road, vehicle, and the driver. But it's not that only one vehicle, one driver, one road is there. There are thousands of vehicles which simultaneously interacting with the road. Even road neighborhood will keep changing. If you keep moving, your road surface will change, neighborhood condition will change, shoulder dimensions will change, weather condition might change if you travel larger, or maybe geometric design will change. So lot of variability in terms of road, lot of variability you might in your neighborhood, there might be different variety of vehicle, you will keep interacting. So once the number become significantly high, then you cannot solve those system by analytical method, then it become like simulation become more realistic. And like here visualization is another addition. You can visualize the system like how it is behaving, that then it become more easy to appreciate. If you see that how vehicles are moving in a particular simulation model, so you will be able to visually check that whether this movement of vehicle is like close to reality or not. So if it is close to reality, you can believe that like at least for first glance things are fine, vehicles are not like running over one over other, they are taking they are not taking abrupt lateral shift. All those things can be very clear with the visuals. Okay. Then these can be of different types. You can have a static system where things like behavior does not change. So whatever behavior is initially, it will not be change over time, it will remain same. But you can have dynamic system where like things get changed, like the driver behavior may get changed, or road surface like keeps changing. So if a vehicle is moving at mid block section, as soon as it approaches to the intersection, behavior might be different because the road component behavior is changed. Then you can have deterministic and stochastic, discrete and continuous, we will talk about. So this is like static and dynamics we have talked about. If any parameter which keeps changing over time, so then it become dynamic system. So traffic is like one of the dynamic system here, like maybe even it's up to you that like what you are looking for, whether you are looking for impact of the road geometry, then you will be might be wide road, then narrow road, and then you wanted to study that like how congestion is forming. So then over the time things will be keep changing. Or maybe if you want to study the driver behavior and aggressiveness, if it is changes from morning to evening, that also you can incorporate, and over time behavior you can see that how much impact will happen because of change in driver behavior. So then that become dynamic system. Stochastic and deterministic means like where you are able to predict the behavior very accurately, so that become deterministic. So wherever that situation come, answer will remain same. But whether traffic system is like a deterministic system? No. Why it is not deterministic?
So every time, like at every second, the change of
So which component is more responsible for that out of three components? Vehicle may not be, because like if you apply same amount of pressure, most of the time deceleration generated that might remain same. Over the time, maybe over years it may change, but not like within hours. But driver behavior will definitely change, and driver cannot like have very precise perception. So it's like it's not if you ask like how much distance from that place to this place, if I ask 10 people, they will come up with 10 different answers, because that depends upon their perception capability, how accurately they are perceiving. If they are not able to perceive the distance accurately, how you will expect that they will react in similar way? So based on their perception capability, their reaction will keep changing, and once you try to like guess the distance, you know that like you need to decelerate harder or maybe milder, but you don't know the exact value that how much pressure you need to give. Based on your expression, like you try to press the accelerator, sometimes it might be slightly on higher side, sometimes slightly on lower side, So even idea is that like discussing this is that like if you expose same driver 10 different time to the same scenario, he might react differently. So then it means it cannot be a deterministic model. So whatever model you are going to develop, if it is having that kind of deterministic relationship, it is difficult to represent the real world traffic stream. So it might represent with lot of simplification. Then continuous and discrete. So sometimes like if you want to simulate the traffic stream and your objective is just to get flow of like at particular location. So here like maybe at every 0.1 second you may not require like to update the vehicle position. So maybe like every 5 second, 10 second is also okay until unless you start introducing some kind of error into your system. So in that case like continuous evaluation of vehicle position you may not require. So you will try to discrete get the system updation at discrete interval of time. So your system become like discrete in time. So it's like that like you are standing on the top of a high-rise building and seeing the traffic stream. So you are opening your eyes, just seeing and closing it for say half a second. Again you are opening. So a vehicle currently here, next time once you open, it is here. So you are seeing in this way. In between whatever happened may not be of your interest. But if you are like say studying kind of accident kind of scenario, where within fraction of second everything happens, there you might require even 0.01 second maybe or maybe whatever minimum possible, because every moment you is important that way. So that will be like more or less continuous, but here it might be discrete in time. Then sometimes even you don't require at every regular interval, because you might be interested in that like to study that how many number of lane change happen. So you want a simulation program to report the status only if the lane change happen. If lane change doesn't happen, it will keep on updating, but internally the data will not come out. So that way like once data is not coming out means you are saving lot of computational time, because the printing it will take time, opening a file and print. So that way like you are making the system faster if you are not asking all the information every time. And that is why maybe you might interested in certain events. So your system might be discrete based on event instead of time. So you can have continuous system, you can have discrete simulation. Then this like already Professor Bhaskar has discussed, like you have macroscopic, microscopic, mesoscopic. Here yesterday talked about mesoscopic. What does it mean is that like once you are looking at very aggregate level, if you are seeing the traffic stream maybe from like aeroplane or maybe a very high rise building where you are not able to distinguish vehicle to vehicle interaction, what you are able to see that group of vehicle. So that whatever parameter you observe, that is comes under macroscopic. So there like aggregate level you will be trying to understand how the vehicles are behaving. If density is high, whether vehicles are accelerating or decelerating, or speed is low or high. So here acceleration deceleration will not come, mostly like you were talking about extreme speed is getting small slower or higher. Then at micro level where you are standing just side of the vehicle and you are able to identify each and every vehicle's interaction, how much is the gap, what type of vehicle it is, what is the like whether it is accelerating or decelerating, what is the exact speed of that individual vehicle, all those informations are known and you are working with that parameter. So that like you are working at the microscopic level. So most of the today's class we will be discussing about microscopic level, and sometimes you required even finer detail. So if you want to have like accident mechanism, like accident reconstruction, and like how vehicle is performing. So the moment you press the accelerator, there might be different in vehicle process happen. before actually that brake get applies. So if you want to study that kind of system, so within vehicle itself, like you will be studying too many other component. So it become like even finer level. And here mesoscopic already you had like it's known to you. So it is in between that macro and micro. Say like if you want to figure it out, like only how many number of lane change happen. You are not bothering about the individual vehicle, only number of lane change. Or a particular intersection, what is the turning proportion of a particular like left turning proportion throughput vehicle and right turning vehicle. So all those calculation, if you want like moderate level, then you may not require even that like this detail. You require like slightly more than this. So that is like you go with the mesoscopy. Okay, so this is like all Google thing, whatever you see, like all the road network, if you see like red, green. So basically you are looking the system at macro level. So green means like there is might be free flow, speeds are high, red means that towards congestion. So till micro. Okay, any question till now?
The way what
Sir, what is the difference between simulation and forecasting?
Simulation and forecasting. So simulation is like you can use simulation to forecast. Okay, forecast means like you are interested in future up to certain time is time that what is going to happen, and that you can get using simulation, using mathematical equation, anything can happen. So means like in future certain time interval after what is going to happen, what will be the scenario, that will comes under forecast.
Is it that in forecasting, a researcher comes to know of a behavior which he may not know initially?
Yeah.
I mean, the behavior may exist in actual reality, but since he may not be aware initially, so he comes to know about it, and then he can test it on the field.
Yeah, forecasting normally we use like if you want to if you are predicting the system behavior just after 1 second, that is actually not the forecasting. Forecasting once we normally we use once your time horizon is reasonably large, which you cannot like easily anticipate. So then using some kind of properties, either using simulation or might be using some kind of factor, you might be trying to predict what will happen in future. Say, and mostly you can use it like forecasting for usual routine event and non-routine event. Say like if it is like you wanted to see that like in particular this link, this is the traffic today. After maybe like using that like growth factor, you can figure it out after 1 year, 2 year, what will be the appropriate flow values in that network. So that is one. Another is that like if you are having a traffic condition which is prevailing right now, how fast like congestion will occur, or maybe if you are working say signalized intersection, so maybe you might be interested in that like at what time the queue length will reach a particular threshold. So that kind of things can also be comes under maybe forecasting, but short term. So whether this answers your question?
Okay.
Yeah, please.
So one clarity I request is like, is it necessary to actually have an analytical model to simulate, or is it possible that you can create simulation without mathematical representation?
So there will be some kind of relationship definitely exists between component. Okay, so like in traffic system, you had like cars, drivers, and road. They are interacting with each other. So if you change any component, you will see the change in behavior. It means they are dependent on each other. So this relationship, how to represent this relationship? So sometimes like if you use machine learning and those things, still there are inside some kind of with the weightage factor, with the connection, some relationship is built, and based on that he is able to answer. Like your neural network inside your mind. So you had like trained your mind over time. That is why you by processing you are able to answer some of these. Even like if you had been exposed to very unknown environment, still you will try to guess. So but there is like whether you are able to explicitly write those relationship or not, but definitely some relationship exists.
Okay.
So so both things are important. Like if you had like mathematical clear analytical model, so there you know that okay, this behavior depend upon x y z parameter, and you will be able to visualize that okay, x parameter is more important or important is playing more important role. So maybe like distance, headway, relative speed, and maybe acceleration, deceleration. So based on their position in the equation, you can figure it out, or doing the sensitivity analysis, you can figure it out which parameter is more crucial. So that gives like more or less like clear picture. So but if you use like say ANN or machine learning algorithm, now in that also people had worked it out. They can figure it out some parameter importance. So there also like although we don't have relationship, but inside you know that like some weightage exists, and based on that it is able to predict.
Okay.
So and in order to develop that weightage, you need to give some real incidences as an example, so that it can fine tune that weightage, so that once you give one input, it will be able to give some kind of output. So in between, without relationship, like it is not possible.
Somewhere it is being built.
Somewhere it has to be built. Otherwise, how it will predict? So if he has to mimic the behavior, like say in actor, if he has to act a particular copy a actor, he has to get that his like walking style, his like speaking style, body movement. Until unless copy that, you will not identify him as an actor. So he has to copy those. So whether like he is copying 2 factor or 10 factor or 20 factor, so realism depend upon that, like how close it is.
Thank you, sir.
Yeah. Any other question? Okay. So this like is well known. So microscopic level, we have these parameter like time headway, the individual speed and distance headway, and macroscopic level we have flow rate, average speed, and stream. So if we talk about like macroscopic level, so which are the fundamental parameter which you think driver might be able to perceive out of these three?
Speed.
This question is for non-IIT student. So you people know, I know. So, these are three. So which one like you think that people can perceive? Density. Okay. So he said density. Any other parameter?
Speed. Speed.
Speed. Okay. Flow rate. So means like once you are in a stream, so which are these parameter you can guess, or maybe you can perceive and react? Flow rate also. So density, how you perceive, because you can see your neighborhood, how many vehicles are there. So definitely you can perceive. Average stream speed. Most of the time, if you are driving, you know your speed. So whether other vehicle are overtaking you or not you are overtaking, you can have some at least reasonably fair idea that what is the average speed of other vehicle. So flow rate is that like you need to measure at particular section that how many vehicles are crossing, but you are not standing at one section that you can count. You are moving in the stream, so you have no idea that how many vehicle is crossing a particular location, because you that section you had crossed. Now you know that like you have no idea whether following vehicle how following vehicle has crossed within 5 minutes. So these two parameters, if driver are able to perceive, so all the microscopic relationship will try to relate these two parameters, because driver might be responding only those parameters which they are able to perceive. So flow rate, like you will not see then the relationship, mostly like speed density relationship will exist in all fundamental model. Similarly, if you see at micro level, so whether you will be able to measure distance headway, so you can see the vehicle and figure it out how much is the gap. So that is like you can get this idea. And what about speed? Your speed, that is precisely known. What about time headway? Time headway is little difficult to tell. So you can perceive? It's difficult to perceive. So distance you can perceive, your speed you can perceive. Maybe you need to mathematically calculate and know that like this is the time headway is like 2 seconds or 3 seconds. So that is like difficult. So most of the fundamental relationship you will see that like they will be developed between distance headway and speed. So whatever driver is perceiving, obviously you will try to develop the relationship from that parameter, because actually driver will be reacting to that parameter only. Then once macroscopic relationship was trying to develop, people first plotted all the observed data between speed and density. Then they see that there is an inverse relationship exists, and then lot of models have been developed to fit within that observed data. So there are a series of models. I had listed only few. Okay, so we'll not go in that macroscopic, but all effort is that how best you can fit to this this fundamental diagram. And this fundamental diagram you see is speed and density, because these two are the which can be perceived by the driver. It's not a speed and flow. So that is speed and flow that derives later on. Okay. Then these are commercial software, but and they might be uh, graded from different point of view, whether they are stochastic or not, whether they are deterministic, whether they belongs to microscopic or mesoscopic or macroscopic, whether they are discrete in time or discrete in event. It's not the comprehensive list. There are many. Even Emerson is not here, so there are many such software. So you can just like just give you it gives a comparative idea that like what are the different models exist and where they fall. Then why we require this simulation model? So some of this is like if you want to do some kind of treatment, say like if you had designed an intersection, so you cannot like build install signals and see that like whether it is performing okay or not, or build rotary and see that whether it perform okay or not. So in these experiments, instead of physically building those structure, you need a simulation model where you can experiment all those things. Or maybe like if you want to test some kind of new innovation strategy, say like there are few innovation intersection design like where continuous movement happen without stopping. So all those you cannot like build in ground and test, because there might be risk involved. If accident happen, who will take responsibility? So initially they get tested in simulation environment, because like you believe whatever relationship you had built, that is like realistic. So whatever result you will be getting through simulation, it might be realistic results. Then many other, like maybe even accident related reconstruction can be done through this only, because once accident happen, you cannot do like ask them to recollide and watch until. So and many of the time you don't have like the video also. So how to know that what was the scenario before the accident? So you based on the data available, you try to guess that what could be the possible scenario, and try to model that collision and whatever is the outcome of the model, you try to match whether outcome is like similar whatever has been observed or not. If it is matches with the existing outcome, you can guess that whatever your assumptions were might be the real assumptions. Okay, then before going into simulation, like maybe we can see some of the videos of simulation, then so that like maybe we can realize that like okay, there is no keyboard. So how to go back from the slide? Oh, the keyboard is there. Okay, thank you. Okay. No. So now this is the simulated network. So this visualization helps you that like to evaluate whether whatever relationship we build, whatever gap acceptance algorithms we had included, whether it is appropriate or not, and then you can change the infrastructure and see that like whether you are able to increase the capacity. If we put like BRTS in the middle or the shoulder side, what kind of complexity you are going to face. Okay. So how many of you are like working in simulation? So whatever, maybe you are, that experience is still there, no? So you have not forget. So yeah, then like people who are like working in simulation, they can very well connect with that. So this is like videos are for those people who are not working in simulation. So how the simulation animation or maybe finally your simulation will look like if you do it for entire network. Then we'll go for some other type of simulation. So where they simulate a large roundabout. You can see that how vehicles are flying. So all these are like maybe taken from directly from Visim. So they might have right hand driving rule instead of left hand. Okay, so this way like you can easily figure it out what could be the capacity of roundabout at particular location. But this is lane based traffic. So similarly we can develop the relationship for even non-lane based traffic also. So maybe like this is one example where you can have Indian kind of traffic stream. Here you see that like vehicles are like not following lanes. Like maybe you will see two-wheelers keep coming. So although it's still like few lane discipline, but two-wheelers are filling in between. So on that side, if you see, so this is like little bit realistic way. So like we stuck in middle. The simulation also like is not able to run that smoothly. So idea here is that if you see this kind of visuals, at least we can have some confidence that it's like little close to reality. All here cows and those things are not there, so you cannot have 100% reality, and there is no encroachment, which is the another feature. And many of the time, like we blame that our road is narrow, but because of that small patches of local encroachment, everything like in that capacity of the network goes very low. Okay, so then yeah, this is like simulation of toll gate. So here lot of relationship like mathematical model comes, like once you are on 2 lane, suddenly road become 4 lane. Now which lane you will join? So this mode choice like this choice behavior will come. So you need to model that on what parameter you will choose a particular lane based on queue length and many other parameters. So based on the service volume here, what will be the queue length, all those modeling can be done. In between like behind this visuals, mathematical rigorous mathematical equation is there, which will be like uh, keep updating the vehicle position and keep deciding whether they will shift to lane 1, lane 2, lane 3, how far they will stop here. You need to have the real data from toll collection, that like uh, minimum how much time they take, maximum how much time they take, how it is distributed, and then randomly you are assigning the service time to each of these vehicles. So all those nitty-gritty detail comes from the field, and then this simulation will look like a real one. Otherwise, like it will not look like a real one. So it might more look like game. Okay. So this like the benefit is that like if you had this, you can figure it out whether 4 toll booth is correct, okay, or you need like 6 toll booth without constructing on the ground. Maybe then we will have just last one. So this is signalized intersection. You can try that what kind of signal cycle you require. So already Professor Bhaskar has discussed like how to optimize the signal cycles, all those things. So here those things you can test like after optimization. vSim does not have like its in-house optimization tool. So maybe like you need to do hit and trial, or you need to use GA something to optimize delay, and then again fed back into the vSim. Okay. So vSim, like always, like even if you want to calibrate vSim parameter, you need to have a separate tool where you will be like changing the parameter and running vSim and again and again, getting the certain output, like maybe either in terms of speed distribution or time adverse distribution, vehicle composition, traffic flow volume, and keep matching with the observed one. So until unless it's started matching with the observed one, your calibration is not complete. So that iteration you need to do it multiple times till you get your calibrated parameter. Okay, so this is all. Again, we will come back to the original business. Okay. Okay, so in microscopic modeling, okay. So this is the some of the standard car following properties which generally models has or at least reflect. So in in microscopic model, there are like two broad scenarios. One is that free flow, once the other vehicle impact is not there, so then that modeling become very easy. Whatever is your speed, if your speed is not highest, you will try to accelerate and achieve your highest speed. That's all, because there is no braking required. So that kind of equation is very simple. Achieve your desired speed within the like depending upon your aggressiveness level. If you are very aggressive, you will quickly achieve, otherwise you will comfortably accelerate and achieve. But in other case, once other vehicle is there, then that situation become little bit complicated, and there people had observed and listed these few parameters, a few behavior which might be which should be reflected in real traffic stream. First thing is called stimulus response process. Like this car following behavior is a stimulus response process, means like you will be keep observing some of the parameter and keep responding to that. So these parameter can be anything. These parameter can be your just a minute. So these parameter can be your distance headway, these parameter can be relative speed, these parameter can be next vehicle speed, anything. But you will be continuously perceiving that, reacting to that. But in this process, once you are perceiving some of the parameter, you are reacting to that, there will be always a delay. And that delay plays important role, that you will perceive, process it, react it, then there will be delay equivalent to your perception reaction time. So every time whatever parameter you will observe, you will not react instantaneously. Your reaction will come after delta t time. So this is one clear behavior which any simulated model should reflect. So their reaction should not be immediate. Then approximate process. So like we discussed that this is like major component out of 3 component. Human is that where lot of approximation or maybe uncertainty exists. So their behavior keeps on changing depending upon their mood. If they are in aggressive mode, behavior will be different. If they are in relaxed mode, behavior is different. Even though person remains same, vehicle remains same. If he has time pressure to reach the particular location as early as possible, then he might be moving aggressively. So in that case, like he will be perceiving the parameters and trying to react to that. And in this process, his like perception will never be very deterministic. So he will guess that what is the distance headway. He will guess that what is the relative speed, because he does not have any data what is the speed of leading vehicle. So it will depend upon his guess that whether leading vehicle is accelerating or decelerating. Now that is why the brake light concept came, because like sometimes if deceleration is very small, a leading vehicle is decelerating with 0.5 meter per second square, so you may not able to perceive unless they are very close. But as soon as you start decelerating, your brake light is on. So now that is like additional information to the driver that following a leading vehicle is definitely decelerating. So that way, like it become additional information, and once it's decelerating, you are moving at same speed. It means that is a risky situation. If you don't do over the time, you are going to hit that vehicle. So that kind of information you get, but you don't get at what rate it is decelerating. Okay. So currently, even like one debate is going on, like maybe in research community, that like maybe whether we should have variable brake light. So maybe kind of indicator 30% braking, 60% or 100%. So depending upon brake intensity, whether, but we don't know whether that is going to help the following driver or not, but it might, it may not. So somebody can try this. So that way, like it will be whatever perception you will make, that will not be deterministic. That will based on your approximate value. Like it's like everything whatever you will perceive, that will keep changing. Perception will keep changing. So it will not be a deterministic one. Then asymmetric to okay, there might be few more things before we start talking about this. Okay, so regarding that, like perception reaction like difference, how people perceive and react. So one experiment, this is like a real experiment which is done by one of the PhD student. So where we had like camera on the following vehicle, and this vehicle was also like our vehicle, and we try to follow following car lane display, like lane display. So both the vehicle was controlled by us. So there both vehicle volunteers were there, and this camera was properly calibrated. So every instance we can figure it out what is the distance headway, and both were equipped with the GPS. So we know that what is the current speed of those vehicles. So we can have relative speed, all those things we can figure it out. Then subsequently, once we plot the reactions of both the vehicle, so here this is time instant. So the black one is the acceleration, the red one is acceleration and relative speed. Black one is the relative speed, means if relative speed is positive, means leading vehicle is moving faster or accelerating. If relative speed is negative, means that leading vehicle is moving slower. So now if you see this, like here leading vehicle is accelerating. So if it is accelerating, the distance between two vehicles are increasing. Then what will be the response? Following vehicle will also try to accelerate. You see that, like after red one. So after some time start catching up. But there is a difference, time difference, and that is actually perception reaction time. Similarly, if you see deceleration, leading vehicle started decelerating, so that's why the relative speed become negative. So here, because it's decelerated significantly large value, quickly following vehicle reacted, but there is a time difference. So this, like is clearly observed if you draw the these like actions of the following vehicle and leading vehicle. This gap, time gap, you can like figure out such instances, and you can figure it out what is the reaction time of that drive. Okay, so these are few values, we can skip this. Yeah, then we are talking about like the response to different stimuli, like driver response, like if leading vehicle is accelerating, means the distance headway is increasing, in that case the response, versus if leading vehicle is decelerating and your space is decreasing, that way response. In both cases the response is not same. Not same means in terms of like not we are not talking about in terms of magnitude, in terms of like sign, like in one case you need to decelerate, in one case you need to accelerate. Say relative speed is like one case is plus 10 meter per second, means like leading vehicle is moving 10 meter per second or 10 kilometer per hour faster, in other case 10 kilometer per hour slower. In both case the way you react, that magnitude will not be same. Once it is relative speed is negative, you will react harder, because like you are going to hit that vehicle. So here you will be more sensitive, you will act quickly, at the same time you will react harder, versus once it is moving faster. So if it is moving faster, your gap will increase, but this is not like create any safety issue to you. So in that case it becomes like you can comfortably accelerate. It's not become urgency that like you accelerate, otherwise like something will happen. So that's why like in case of space decrement versus space increment, both the behaviors are not symmetric, so their response will be different. Okay, I think, yeah. So like with the relative speed in the same experiment, we try to figure out like what are the following vehicles response, acceleration and deceleration. So here you could see that like similar kind of relative speed. In one case, like once it is -8, so here response is changes like from this range to this range. Once it become +8, the response is much smaller, because like why to aggressively accelerate? Nothing, like we may not feel that kind of urgency. Even if we accelerate comfortably, nothing is going to happen. And this is the real behavior which you will observe in deceleration case, or in those cases where space is going to decrease and creating threat to your safety, you will be more active. Even it is observed that reaction time, if you might have noticed in that graph, while in deceleration reaction time is small. The driver quickly react in terms of space decrement case than the acceleration case. So these are like the some of the observed fact from the real stream, which your model should also reflect what you are going to use to simulate. Then okay, one more important parameter was that like a drift behavior, means that if you ask two vehicles to move, follow each other, so suppose the leading vehicle is like somehow you fix the speed. So by some mechanical means that this vehicle is moving at 40 km per hour speed. Now you ask the following vehicle to maintain the same speed. So what will be the scenario? What speed he will be moving over the time? Leading vehicle is fixed at 40. So following vehicle is like manually driven. What will be his speed? Less than 40? So if it is less than 40, then distance will keeps on increasing. So over the time it becomes 500 meter and 1 kilometer.
What's the objective? So you have to follow the vehicle.
So leading vehicle is moving at 40. So 40 is not obviously your highest speed. Your highest speed might be 80. Whenever you get opportunity, it is anticipated that like you will try to achieve that highest speed. So in that experiment, so leading vehicle speed is fixed. It's not changing. So question is that what will be the following vehicle response? At what speed it should move?
Sometimes less, sometimes more than
Sometime?
40. Sometimes if it is traveling at less than 40 and distance is more, then it will try to be like the speed will be more than 40 so that it can overcome that distance.
Never cross 40.
Oh,
If it never cross 40, then increase.
it will oscillate for sure.
So it will oscillate like this. So you will try to maintain average speed as 40. But in order to maintain that average speed 40, because like again you are human. So if you had like feel that okay distance is increasing, you know that now you are moving slower. So you will accelerate. But you don't know that like when your speed become exactly 40. So you might go to 41, 42 and then you will be seeing that okay distance has been reduced. Again you start decelerating. So that way like you will see that your average speed might be 40 but you might be ranging from 38 to 42 or maybe 35 to 45 depending upon your perception capability. So this variation will be different for different person. So somebody is like Formula 1 racer, he might be very much able to precisely figure it out when he is moving faster, when he is moving slower. So he might be maybe 39 to 41. But this band will always be there. This band they called it drift. So here like following vehicle will never be at constant speed even though leading vehicle is like at constant speed. There will be some fluctuation will keep going on in reality. And that is because of perception capabilities limitation of the human being. And we'll see that like all VSIM is based on this perception capabilities like this fluctuation. So
We all experience it, right?
yes. Yes, like if you drive in highways, and like then if you are moving sometimes like it might be milder. So like if you are moving at 80, so then this drift will be smaller because you are already at higher speed. So there even you don't mind even if the gap increases little bit. But if once you are constrained, you will desperately try to maximize the speed. So here drift will be higher. Okay. But this drift will be there. So maybe like next time once you drive, try to see that whether that thing are happening or not. Okay. Then you able to correlate better. Now we'll try to talk about some philosophy which is actually philosophy of VSIM. Okay. So although we'll be keep talking VSIM doesn't mean like I am VSIM representative. So I'm not from TTV. So so it's like because we had worked on more on VSIM and that we find it like it's like has better capability to represent Indian traffic stream than Emerson and many other which is like more lane based traffic. So that is why like maybe frequently you will see that like VSIM name will come. Okay. So there is like a concept called like psychophysics. So which talks about like quantitative relationship between physical stimuli and the sensation. So this is little kind of different, than whatever we are talking about traffic flow. So this is like kind of a absolute threshold where you are able to perceive some activity with 50% of time. Say like if I just drop a blade from here, so even everything pin drop silence, so sometimes you might be able to hear, sometimes you may not. So we are assuming that this noise created is of that level, only 50 times of you are able to perceive. That becomes the threshold. If it is more, noise is more, you will be able to perceive like more times. Okay, so that threshold, this whatever area of physics which deals with this kind of thing, that is called psychophysics, and there are many such experiments. So maybe like if you had a candle, you keep moving, you move so far, so from that distance sometimes candle is visible, sometimes not visible, so that become your threshold, that where 50% of time you are able to see and 50% of time you are not able to. It doesn't mean candle is not there, candle is still there, but that is become your limitation that you are not able to perceive. So this becomes like threshold of your senses. So like you are like playing with the extreme conditions where sometimes you are able to, if you put too much pressure, you may be able to perceive, and sometimes just not. Okay, so similar thing with the hear, similar thing with the touch, smell, all senses. So there is some threshold exists. So idea of discussing is that like, because all the drivers are human being, and all the information which you gather for the traffic through your senses, and this senses has certain threshold, and mostly will be working with the vision or sight, because whatever distance, whatever things you are perceiving, most of the time you will be perceiving through vision only. Now in that case, now let us take an example like where there are two cars. So they are moving in a particular road, in single lane road, there is no overtaking possible. So initially this like distance between these two vehicles is L. Assume that this L was like 1 kilometer, initially so large that you cannot perceive. Okay, in that case maybe your speed is currently V, and maybe this might be moving like more than V. So this V2 is like much higher than this V1. Okay, but distance is like very far, maybe 2 kilometer if you can see. So you are not able to see that vehicle initially, or even if you are able to see that vehicle, you normally don't bother because distance is too far. Obviously 2 kilometer you will not start decelerating seeing that that vehicle is stopped or something. So what will happen over the time? If you, so you will not bother means you will not act, you will keep moving at your own speed. Okay, sorry, this is like wrong. This speed is like smaller, this speed is larger, you are moving faster, leading vehicle is moving slower, otherwise like you will, distance will keep increasing. So in that case over the time if you don't act, what will happen? Distance will reduce. So when you will act?
When you see.
So you might be able to see like even a kilometer if it is like wide road and it's open ground. So whether you start reacting from that? So when to react?
Moment might be right that it's leading back and going slow.
So when you will able to do that?
Only when a distance, because the person the distance.
So there will be some threshold somewhere.
Side distance depends on person.
What is? Yeah.
Distance also.
Side distance means
Stopping side distance.
stopping side distance, say like 200 meter. So whether you will be able to perceive that 200 meter is happen or not.
Is the side of the side also matter? Because you see the point when it is very far and then
Yeah, it obviously it once it become closer and size become bigger, your perception will be like more precise. You will be able to perceive the distance, assuming that like even though once it was 1 kilometer, you are able to perceive but vaguely. But as it comes closer, your accuracy will increase. So at least like if somebody asks like this, how much is this distance, you will not say obviously 1 meter. But if I say from here to here, your error might be in the order of meters. So if the things are like closer, then error will be obviously lesser. But there will be some point of time where you will realize that okay, now these are dangerous. I am moving faster and this is moving slower. So yeah, so initially driver is not realizing. So what is happening? Distance headway is like decreasing because relative speed is this much. So there might be some point where it realizes that okay, now I have to take action. So what action you will take? Decelerate. So if you start decelerating, so what will happen? Relative speed will also decrease. Okay. So relative speed also decrease because still is you are moving faster. So still distance headway will keep decreasing. So here relative speed become 0 at this location. But whether you will be able to perceive that now you are moving exactly at 40. So we had discussed that thing. That's why we had discussed earlier. So it's just not possible that to realize that now I am exactly moving with the speed. So there will be some error, perception error. So you will keep decelerating. So if you keep decelerating, what will happen? Your speed becomes slower now. The leading vehicle speed becomes faster. So distance will start increasing. So you will start moving in this direction and might be like distance start increasing slowly. So if distance initially start increasing, you may not able to perceive. But obviously if it become like 200 to 300, you will be able to sense that now something is changed. So there might be some threshold. So I don't know whether it is here or here. For different person, there might be some location where if distance headway changes from here to here, initially at 0 distance headway was this, now distance headway has been increased to this. Oh, this is like, so maybe this much change is perceived by your brain, and once you perceive that now it is increasing, what you will take? Again you will try to accelerate because you don't want too much distance between these two axles because you want to maximize your speed. If you start increasing the speed, so then like again distance headway like still you are moving like slower, so distance headway will start increasing. Again it becomes 0 here, but again your perception capability comes into picture. You will again switch to other side. So you will see that again you will be doing this. So this cycle goes on. So over the time you will see that like you will be able to initially this perception might be, this variation might be large, but over the time you will be able to fix up some location or maybe some range where you will keep changing. So some amount plus, some amount minus. So this becomes like your drift. So here you are changing the speed because of that relative speed exists. So this is actually your drift. So this, beyond this, you cannot precisely perceive. And what is these lines? Like if you uh, do this experiment, this is for one driver. If you do 100 driver, so for driver 1 this was the threshold, there driver 2 there might be this threshold, so there might be different threshold. You may get a kind of this kind of front where people are making the decision or people start perceiving those. So this is called that threshold. And based on this threshold, people start making decision, increasing or decreasing, or become, at least they become aware, like they are aware of the situation, but they start taking action. So if you do 100 drivers, you might get different point. If you join all these perception threshold, you will get one is towards like negative relative speed, another is towards positive relative speed. Now if you see this, so I'm not good in that, huh? So this distance versus this distance, so this is smaller, so it's not just by mistake. Why this is smaller? This side is smaller threshold, once it like come closer to the zero, this is larger. Why it is like this? So we talked about like it's not asymmetric, it's not symmetric. So you behave differently in deceleration case, you behave differently in acceleration case. Acceleration case you are casual, so your perception errors are more. In deceleration case you are more cautious, so your perception errors are less. So this is less, this is large, and that is why like you will have different ranges. Okay. So if we see now the psychophysical model of Vesim, so they use similar philosophy. Okay. So only thing, now you will see instead of one threshold they had added one more, they had added like few other. This is deceleration, this is collision range, because this is bare minimum distance headway which you need to maintain. So they put some limits, some ranges based on the like different driver study, and then maybe like some many of these parameters you will be actually calibrating. So Vesim has like C0 to C9 different calibration parameter, and you try to tune them in order to match with your real world traffic. So in a way you are basically changing these threshold and trying to match that okay outcome in terms of if you are interested in macroscopic study, to speed flow density you will study and try to see that like is matched with the real world. So you are happy that now whatever is my threshold, it might be representing the real world threshold. If you are wanted to have microscopic, then maybe time headway distribution or speed distribution or whatever parameter you want, that you will calibrate and keep fine tuning all this threshold only. Okay, so this is clear. Okay, so at least you one model you had studied. Still you will not able to run Vesim with this. There are a lot of other thing to study, but philosophy of Vesim is like this. Again, this we can skip, this we can skip. Okay.
That model is to figure out if the following driver wants to accelerate, right? Sorry, wants to overtake.
So this is like I am talking about car following model. So where we assumption is that like vehicles are moving in a single lane and they are following each other, they don't have option of overtaking. So there is a separate class for lane change model. So you add those whenever you are not happy with the leading vehicle and you end up with situation where you need to decelerate. first you will check whether you are able to change the lane or not. So then lane change model will come into picture. You will evaluate whether this is good for lane changing or not. There is no vehicle on the side, you will switch. So from car following model, you will switch to lane change, and if that becomes successful, now you will be in different lane. Again, if next vehicle comes under this lane, car following model will come into picture. So car following alone will not be able to give you the entire traffic string. So initially, if you remember, we had talked about two-dimensional. So here these are one-dimensional. You are talking about like only longitudinal interaction, car following. Intermittently or discretely you are changing lane through lane change model. But in our case, where two-dimensional interaction is there, maybe these two model cannot be independently, it has to merge. So that we'll discuss towards the end. Okay, we'll quickly move.
Just one query.
Yeah, please.
Under which conditions it is good to adopt VISIM and under which conditions it is not so favorable?
Yeah, VISIM is like mostly good, but it is like all depend upon how accurately you calibrate. So if you are not able to calibrate properly, it will give you some junk value. So if you are interested in microscopic parameter, then calibration has to be at microscopic level. If you are interested in macroscopic parameter, then you can do at macro level. So it's not that you are calibrating for a speed flow density and then you are trying to study time headway distribution. So that is not possible. Okay, it like majority of cases like it gives VISIM. So whatever is my experience and other simulation model, we had not find which is like that kind of flexibility to represent Indian traffic. So they had lot many parameter now it is like inside which generally we don't play with. Sometimes it is like open, you can change those values also, but to more fine tune the for Indian condition. So there are like diamond queuing theory and even changing lane within the lane. These are few standard which is like you require to definitely have no lane display. Then there are few other parameter if you go inside which you can fine tune to make it like more realistic to Indian condition. Okay, so all depends upon how good you are able to calibrate your model. Okay. So any other question from online? Recording, why you are starting recording? Just stop the recording. This MS team. Surya. So it's showing this Nijamuddin has started recording. So this should not be recording should not be done here. Okay. So he is online. Just check. Okay. Okay. So these are like a few models which are like very basic, like pipes model, force model, where it is very starting. So we will talk few of them, not like initial ones. Initial ones like maybe very basic, where if two vehicles are there, how the acceleration of these vehicles will depend upon the relative speed of between two vehicles. So these are very initial days, like in 50s. If relative speed between two vehicles become 0, it means that like you will not react at all even though you have 500 meter distance, which is not the real time. So if distance is large, so you will still try to close in even if relative speed is 0. Then similarly force, like the similar way with some sensitivity term here, but formulation is same, philosophy is same, that your reaction will depend upon relative speed between leading vehicle and following vehicle. Then afterwards, like General Motors develop one model where they come up with a more detailed version that vehicle action is not only depend upon relative speed, but it also depends upon relative distance. If this relative distance is large, so if your relative distance is large, then your accents will be lower. No, it should be higher. So this is like his own vehicle speed they had added up, and another major change was that like they had added this delta t, which is means that you will be like here you will be reacting after delta t, even though you are getting data at time t. So you are measuring the time relative speed at time t, but you are reacting at delta t time later. That your reaction depend upon your distance headway. If distance headway is, so how come this is distance headway is large, then if there is large distance headway, reaction should be harder.
So it's inverse of the spacing, right?
Yes.
This is the acceleration of the T, right? And
This equation is written correct, but
there is speed of the n plus 1 acceleration. So
So actually, we are predicting the next step, that is after reaction time. What will be the prediction based on the current estimate? So this XE are the current estimate. So based on the current estimate, we are predicting that T plus delta T. So what will be our next estimation? And so if the distance is more, then
your action will be less.
and more the distance, then you have more opportunity to accelerate. So that your acceleration will vary the distance, the more you can accelerate.
Yeah, but like here reaction will be lesser. This value is higher.
So there is a L term there.
L is always like positive. It will not be negative. Otherwise, it will go in numerator. Okay. So this is like this equation is correct. Somehow we are not able to get the correct context. So this is actually the sensitivity term, which is this entire term. So this actually governs that how much impact of this relative speed will be. If relative speed is 10, if distance headway is large, then this value should be higher. Something is so we'll figure it out. Okay. Okay. So then subsequently after that, like there are a series of model comes. So some are like analytical, some are rule based, where like maybe you have certain like rules that following through they will be able to respond. So we will discuss like how much time we have. So till 11 o'clock we need to finish. No?
Yeah.
So we will go less on this side. Okay, we will discuss more on like comprehensive model, which is actually applicable in Indian context. Okay, some of these models, which is actually initially developed and then subsequently people try to modify that equation for introducing two things. One is that heterogeneity, because most of these models initially they had been developed for uniform traffic, like assuming all vehicles are car. Then they try to see that like how different parameter will change if vehicle pair changes. So that kind of modification. Then some people also tried that how this model will change if we try to incorporate no lane discipline kind of concept also, where lateral veering is also part of it. Okay. So that we will see very briefly. So this is a standard way like car following model is like represented. You have this leading vehicle, following vehicle, spacing, double dot means acceleration, single dot means relative speed, all those standard representation. Okay, so this is a GHR model where acceleration of following vehicle depend upon the relative speed and the term which is like space leading your own speed divided by certain sensitivity term, so which we had seen in previous model also. Okay, so if you here in previous model there was like fixed value, so here alpha and beta you can choose different combinations. So depending upon the combination, the impact of x is like gap. So if you had like beta is 2, the impact of gap will be more. If beta is 0, then impact of gap is not there, it will be like converted into pipes model. So this distance headway has no impact if it beta becomes 0. Okay. So that way like these models are more generic. If you keep changing this value, you will end up with different past model which is developed. Okay. So this like subsequently people modified, added few more para terms in order to make it more realistic. Okay. Then these are like different class of vehicle. Philosophically they are different. This is like safe distance model, that vehicles should maintain a safe distance which is like equivalent to vehicle length, that is like leading vehicle length, that much distance headway minimum it should be. Then this is Vt. Vt means like the current speed of following vehicle and T is the reaction time. So this much distance, because like before a vehicle react, this much time will be required. So this much will be the definitely a distance which is required to maintain with the leading vehicle. Plus, if leading vehicle is stopped, you need some space to like travel before you come to a stop. How much distance you need to travel, that is this v square by 2b. So you need to maintain this kind of distance headway with leading vehicle, but this is slightly unconservative. Every time you are assuming that like a leading vehicle is going to perfectly stop, so that is not the case. So then subsequently lot of modifications come under this. Then that modification is like, then the Gibbs has developed one model where like your speed will be either of these two. Okay, so one of the philosophical difference in these models, like if you see driver perspective, so what you do, how you react, you press accelerator, whether that governs the speed immediately, you control the acceleration. So but many of these models talk in terms of speed. Okay, so that is like, but ultimately through acceleration you can again convert into speed, but they directly relate with the speed instead of acceleration. So here one is that like your free flow speed, maximum desired speed, versus the speed which is governed with the current scenario. So this maybe like will not go in detail. Okay, so either of this, if you are able to the other impact is not there, so maybe like you will have this highest speed in case of free flow condition. In other condition, force flow condition, this equation will come into picture and your speed will govern with that. So subsequently Gibbs model is modified with the by the Gune, which was the reasonable first attempt to incorporate no lane display as well as the heterogeneity. So here two terms was important. One, he said that maximum escape speed, that if a vehicle veers, means like you are in car following mode, so in Indian traffic whatever you do, you veer laterally and try to escape. So what kind of veering is required? if veering is required is large, so obviously your probability of veering will be lesser. And after veering, what kind of speed you will get, what kind of speed is available. If you veer and there is another vehicle, then obviously in that case you will not veer. So after veering, what kind of speed you are going to get, that is also will impact your veering. So in these cases, like they try to incorporate both. So how much wear is required, and after wearing how much speed you will get passing through the available gap. So based on that, they try to develop the relationship. So using this combination of both the equation, you will be able to figure it out, which is the which will be your final speed based on that condition. So this, like if you read Gune 2007 paper, lateral discomfort, they had lot many detail where they no, they had not considered. They had like a single mid block data. But that was the first paper which I feel that like they had talked about even lateral shifting and those things and all together. So here there is no separate lane change model, because bearing itself is like lane change model. So that becomes like towards the two-dimensional model instead of talking in single direction. Okay, then this we can skip. Maybe we can go with the rule-based model. So here in this rule-based model, there are like various different model comes. Cellular automata model also comes under rule-based, where there are certain rules, and based on that you keep reacting. So if we say rules like this, so your distance headway got categorized into 6 category. Okay, so maybe your distance headway can be very small than the desired one, it can be very large than the desired one. Maybe desired one is like maybe if you want to maintain say 1.5 second of time headway, whatever is the current speed multiplied by 1.5, that become your desired speed, desired headway. So if existing space is much larger than that, maybe 5 times or 7 times, then you categorize into very large. So basically this becomes qualitative. So instead of actual number, you had divided into certain group. Similarly, relative speed between two vehicles are also got categorized into 6 category. Near zero means like plus minus 1, because like why they do it category, because they are going to use fuzzy logic, which has that kind of flexibility that there will be some perception error. It will not be deterministic. So there will be sometimes for same kind of combination you might be react differently. Like same kind of situation you might react two different ways. So so that is why like instead of actual number they will work with the category. Now based on the combination of this and this, you might react to that. This is like leading vehicle acceleration. So if they are acceleration, leading vehicle is accelerating, that also they divided into this category. If leading vehicle is decelerating, that they also divided into this category. So now you take an existing scenario and try to figure it out. If your distance headway is very small, relative speed is like maybe slightly following vehicle is like moving faster. So this is small, this is faster, maybe what will be your reaction? So that kind of rule base they had built, like here at time t, if distance headway is very large and relative speed is moderate negative, acceleration of leading vehicle is negative, then you should act like this. So that kind of rule base they had created, and based on the existing scenario they try to figure it out where it lies, and then they keep executing that kind of rule using like fuzzy logic theory. So where like they define membership function, some type membership function overlap. So that like added to a little bit kind of stochastic in the prediction. Okay, then this is like a entirely different concept in the modeling, the cellular auto-beta mesh model. So most of the time what we deal with like the real numbers, like speed is 40.2 kilometer, our distance is 3.6 kilometer. So while doing this computation in programming, so you need to define these variables in real number, which requires larger space inside the computer. Integer versus real number or integer versus float, their storage requirement will be different, and their processing of integer is easier than processing of the real number. So that was the basic concept. They wanted to make the system like more computationally efficient, because that was the major challenge, that like you had a realistic model but you cannot simulate the larger network because you don't have computational capability. So how to simplify the system in such a, as your simulation model in such a way that you will be able to compute faster. So in that case, what they did, that entire road they assume that is in grid, and grid size is such that only one vehicle can occupy that one grid, and so vehicle will be either in this grid or in this grid or in this grid. It cannot be in between. That was the basic assumption. So with that, they assume certain grid size. Now because vehicle can be here or here or here, so obviously speed also become integer, either 1 cell per second, 2 cell per second, 3 cell per second, and that way like maybe 5 cell per second represents 75 kilometer per hour. So one cell become automatically 15 kilometer per hour. So your speed also become discrete, either it will be 15 or it will be 30 or 45 or 60, in that way. So speed got discretized, space got discretized, time, obviously this is a discrete model, at every regular interval we are going to update the vehicle position. So that way now our distance headway, either it will be 1 cell, 2 cell, 3 cell, so everything become integer. Now nothing is the like real number, so that then computational become easier. So in this case, this is just one example. So like currently this is the scenario where these numbers are representing the speed of that vehicle. Okay, so like this first vehicle has speed 2, this has 1, this has 1, this has this is like the at time 0 you had this scenario. Now you wanted to see that like what will be the scenario after 1 second. So if your speed is 2 but only 1 cell is empty, can you move 2 cell? You cannot. So you have to decelerate. So you have to decelerate and your speed should be only 1. So here you cannot accelerate, but you will decelerate, your speed will become 1. Still we had not changed the position. We are just changing that, calculating that whether vehicle will accelerate or decelerate. So in this case, this vehicle will decelerate. Here vehicle speed is 1, but gap available is 2. So this vehicle can move 2 cell, because maybe maximum speed is 5 cell per second. So it can increase the speed. So this vehicle's speed become 2. It's accelerated. So similarly here, this vehicle speed is 1, but what is the gap? 0. So this vehicle will decelerate and become speed 0. And this vehicle has 0 speed earlier. Now it has 1 cell. So it will accelerate and speed become 1. Now you had calculated the acceleration deceleration of all vehicle. Now you will update the position. Okay, this we will talk about later. So this vehicle speed is 1. So it will update to that got changed. So this vehicle speed is 2. So it will move to 2 cell. So now this vehicle is here. So this was 0, so it will remain at that location. So this vehicle speed with 1, so it's got 1. So if they follow only A, B and D, so this become like very deterministic kind of model, and which is like everybody realize that like traffic is not deterministic, there should be some randomness. So they put some randomness parameter that like randomly some vehicles speed will be changed for no reason. So assuming that some driver might overreact or underreact, but not all drivers. So maybe like with 30% probability or 20% probability, that you will keep wearing and try to match that whether your outcome matches with the realistic data or not. So here 1/3 means out of 3 vehicles, 1 vehicle speed will be randomly reduced by 1 step, not like at higher step. So here it was 1, it becomes 0, then this vehicle remain here. So that way like you will keep updating this vehicle position using these rules. So this become like the, this is basically cellular automata is physics based concept. So they applied in traffic movement, and that it become like quite popular at a time, like maybe around 90s. Subsequently, what people did, so here like major challenge was that speed will be like 15 kilometer per hour, or next speed will be 30. In between there is no speed. So similarly position will be like at 0, or maybe if cell size is 7.5 meters or maybe 7 meters, so it will be 0, 7, 14, that way. So people by like further divided these cells, and even they divided like horizontally, vertically in all direction. So now initial width was 3.5 meter, length was 7 meter. Now you can have like even a smaller two-wheeler also. So they like further divided in such a way that even a smaller vehicle can occupy just one cell. Bigger vehicle can occupy multiple cell, but they will never be in between cell. So it will be equal number of cell, either integer number of cell, either to this if car comes, so that car might occupy this 4 cell instead of 1 cell. So still processing will be in terms of integer only, but this will have more realistic. Now because vehicle will be moving 1 cell, so now this was like 7 meter, now it divided by into 4 cell. Now you have like maybe even 2 kilometer per hour also you can represent the speed. So that kind of multiple modification has been happened, and then people have like parallelly developed the lane change model as well. So but these models plus point is that they are less computationally like requirement. Their capability are very high. You can simulate larger network very easily. So any question on this?
What was the actual problem over here? Because other models can still do this, right? So what is on the computational power?
So there are like different philosophy, and computational power was definitely a challenge in 90s and 20, because if you wanted to simulate a larger network, so then you have a challenge. You cannot like predict like, because your simulation will help you to forecast if you are able to simulate like 30-minute scenario less than 30 minutes. If it takes more than 30 minutes, then you cannot forecast. So
When you said subdividing into smaller grids, this is not finite element, right? You are still representing a vehicle n times of
yes,
only n times of that.
yes, n times of that. Okay. Now instead of vehicle length become 1 cell, it might be n cell. Now with that, like you are able to incorporate heterogeneous vehicle. Earlier all vehicle size were equal to the cell size. Now one can be 2 cell, one can be 3 cell. And lateral shifting also, like earlier it was only in terms of 3.5 meter. Now you can have 1/3 of that. So that way like basically you made it more realistic. So you created more classes in between. Okay.
So just that in electricity, like Well, let us take one city and one intersection. 70 to 80% two-wheelers are there, and car and as well as the public transport remain same. So can we use these kinds of models?
There are models, but they had their own challenges. Okay, so these models also had their own challenges, because now how to get that random parameter that to change the speed. So again, if you cannot get this in from field, you need to fine tune. Then here whatever cells you are dividing, in order to get more accuracy, you need to divide more fine cells. As soon as you have more fine cell, your computational efficiency will go down. So accuracy and computational efficiency, somewhere you need to compromise. Okay, and every philosophy has its own limitation. So here also there are few limitations. We will not go in detail. If you talk see that like how cellular automata model has been developed, you will see a series of development. And cellular automata has like a large application in multiple fields. Even in music also people had used. So if you had different bits of music pieces, just randomly mix, you might create some kind of new music. And if you mix with certain logic, you will be able to create a new music. So without doing much thing. So there are like entire different philosophy with the cellular automata which used in entire area. Okay. So then this is another model which is like was quite potential, but lot of computational power required. So that's why it's not working. So we'll go talk about only philosophy of this. So suddenly you see why I'm talking about Ceylon. So this kind of, assume this kind of terrain, okay, where you have hills and valleys. Now if we start pouring water from one side, how the water will flow?
Right.
So it will go to hill and come back? No.
It gravitationally
Gravitationally flow, but through valleys only. It will not go to the hill until unless the water level goes up, and then like maybe it might go some of the small over the small hills, but not obviously not the bigger one. So what these hills are, so basically they are like you can assume that they are threat or maybe threat resistance against water flow. So higher the height, higher the resistance. So water try to minimize the resistance so that it can flow efficiently. Okay. So this same philosophy try to visualize on road. So your road, these edges are the hills. So where like you create such kind of function that which has like very high value. So vehicle will never go out of it. So like this is one road edge, this is one road edge. Now vehicle has to in between. So these kinds of function you can create, and then in between all whatever vehicles are there, they are also you can treat as a hill, but moving hill, because vehicle cannot go over it. So you have to create that kind of height or that kind of resistance that vehicle in no case get minimize his like all flow summation to move over it. But now if you consider like pothole on the road, they are also some kind of resistance, because generally you will try to avoid. So depending upon the size of pothole, you can create hill. So if its pothole size is small, maybe hill, a small hill. So once you move over it, you need to pay cost, you need to reduce your speed, you need to face the resistance. So that way, like entire road including all the vehicle, you can create that kind of 2D geometry, 3D geometry, and you try to optimize the vehicle flow in such a way that like this resistance, summation of all the resistance in the path is minimal. So that is called potential field model. So here they try to figure it out a path which is have minimal potential. Okay, so that resistance is minimal. Okay, so mathematically it's like much more challenging to develop all the potential. Even if you had a pothole or a particular two-wheeler, what kind of function it will have, which can create that. Now if you had a say two-wheeler here or maybe car in front, now you need to develop some kind of contour in such a way that all the vehicles which is like coming behind, once they come here they start feeling resistance. If they come closer, this resistance might increase like this. Once they move away, this side also, if they move away by this distance, there is no resistance. But if they start coming closer, they start feeling resistance, so that they should not come and touch each other. So that kind of 3D potential you can generate is like, I mean, this kind of mesh you can functions you can generate, and then you start computing. But now generating this function and calculating the value at every time step become very challenging. Okay, so this is like, but philosophy wise this model was very good. So it was had all characteristics which like our traffic has. There is no boundary. So even if you want to simulate lane base, you can create this lane as some kind of a small hills, that if you can want to change the lane, there should be some gain by changing the lane which can counter this resistance. So all those philosophy you can build in, all sorts of model you can develop using this model. Yeah, I think there might be, this is like developed by Professor Partha Chakravarti in IIT Kanpur. So that is like in 2002 and 4. But it's not worked on like in future because just not possible. It's like lot of maths involved and lot of calibration is required. And for this calibration, you will not get any data from field. Everything is hypothetical. Okay. So then this has like all the steering and those concepts. Like here you have not only direction movement and steering also together. So that way like it become 2D model. You are not looking only in one direction, you are looking on the side also, that if we move in this direction, how much resistance we will gain. And you will add up all the resistance, all the possible in your steering angle capability, what are the different paths possible. All against all path you need to calculate what is the resistance. If whatever you will choose that path for which resistance is minimal, and that you will adopt. Okay. Okay. I think that is the last one. Okay. Any question in this? Okay. So otherwise this will be the last slide. We'll talk about like this update scheme, because like if you see cellular automata model, so there is like sequential and parallel update. This two term you remember, we will go to that cellular automata slide. So in all simulation model, basically we do that. We calculate the reaction of each and every vehicle and update the position after delta t time step, or whatever, if you consider 1 second, you update that. So now here in updating, you can do two ways, sequential or parallel. So here, if we calculate for this, it become 1. So we can immediately change the position, or maybe like we will start from the leading vehicle first. So if here the speed is 0, so it become 1. So we can immediately switch this. So that is like before calculating the next vehicle, we can update the position. So then this gap become 1. So this speed, instead of like 1 become 0 here, it will remain 1, because now this vehicle is moved to this place. Okay, similarly in this case, because this vehicle moved to this place here, now this vehicle has, like before we calculate for third, now it has 3 gap. So that is become sequential update, where you are calculating reaction, updating, calculating reaction, updating. So this is one way. In other case, we had calculated for all with the existing scenario and we had updated altogether. So this is parallel update. So which is more closer to the reality, that you need to decide, like whether it is sequential update or parallel update. No, time is same. Time is same, maybe slightly more computationally efficient. You need to calculate updated position every time. So here question is like, which is closer to reality? Why?
Because that replicates the perception or behavior aspects also when input.
Okay. Anybody else? So here, like once we are calculating for one vehicle, assuming all the vehicles is just sleeping, they are not doing anything. That is not happening. So every time, like every driver is acting simultaneously. So it's not that if leading vehicle is not acting, it doesn't mean following vehicle will not act. So everybody is independently moving and updating his position. So this parallel update become like more practical. So in majority of the cases, parallel update is used, but there is like initially there was few models which might be using initially sequential update as well. So both has plus minus. If you change this time frame of update is very small, 0.1 second or even smaller, then both will give more or less similar result. Okay. Okay, so any question? Otherwise, we will stop here.
So all these models that we have presented can be used only for VC or other things?
No, VSIM has that only psychophysical model. That is one. So every model will, every software come with the particular philosophy, which follows a particular model. So that VSIM model is called Wiedemann model. So that is like based on psychophysical model. So but the researcher name is Wiedemann model. So he has 2 different model and that is like available in VSIM. So similarly, AIMSIN might have the different model. All other models, whatever software comes, they had one underlying a specific model. Okay.
Does these models accept external data? So if I give data from multiple data, then use it.
Data can be used. Data can be used. Like if you had vehicle position or flow values coming in, you can keep using this model and running and feeding back. So it's like Professor Bhaskar has explained yesterday. So like you are getting the data, using your model, predicting and putting back in the system. That is why like you keep updating your signal timing and many other things. Okay. Okay, then thank you. So although we had not talked about any specific model too much, but I hope at least philosophy you got. Okay.
Tea break, right? All these people.
I hope so.
Okay.
Yeah, Surya, just see that like whether tea is there. Okay, so we can take tea break.